Hello, this is Frank Allen of Davis High School. This is a video on Unit 5 of my chemistry course at Davis High School. And this particular video is going to cover balancing reactions. This is concept that's covered in this unit. It's basically a math skill. What you have to be able to do, you have to be able to balance a reaction. We give you the reaction, we give you the reactants and the products, and then you have to tell us how many of these molecules we actually need for this reaction when this reaction takes place. So what we've done here is we've drawn a reaction for the decomposition of water. So without any numbers in front, this means 1, that means 1, that means 1. So if you don't have any numbers, that means 1, 1, and 1. And this is a molecule. So you've got 2 hydrogen atoms and they are connected to an oxygen atom. You've got 2 hydrogen and 1 oxygen. There's no number here, so the number 1 is understood. And here you've got a hydrogen molecule, which is 2 hydrogen atoms attached to each other, and you have an oxygen molecule, 2 oxygen atoms attached to each other. Now when this reaction takes place, it does not take place in this ratio of water molecules to hydrogen to oxygen, because you can see that although we do have 2 hydrogen atoms on each side of our yield sign, we only have 1 oxygen atom over here, whereas over here we have 2. So this doesn't take place with 1 molecule giving us 1 molecule of each of these. So we've got to figure out how many of these molecules we actually have in this reaction, how many of these we actually have, how many of these we actually have. And as I said, it's basically a math skill. So we're just going to start with the first atom. We have to figure out what can go in front. These are called coefficients. So we're trying to balance whatever atoms we have over here, left of the arrow, we must have over here, right of the arrow. Even though this is 2 substances, we have to have the same number and type of atoms over here that we have over here. So we have 2 hydrogen atoms as we have this written. We have 2 hydrogen atoms as we have this written. So that's balanced. We have 1 hydrogen atom and 2, so that's not balanced. So what can we put in front of here and here? It doesn't have to be the same number, but whatever we put in front of here and here, whatever numbers we use, have to give us an identical number of oxygen atoms on each side of the arrow. Well, if we put a 2 here, what that means is we've got 2 of everything that follows. So we've got 2 of what follows, this substance, not this stuff, just this substance here. So that means we've got 2 of these things, and if we have 2 of these things, we have 2 oxygen atoms. And we have 2 oxygen atoms, so this particular reaction is balanced. But when we put a 2 in front of here, we have 4 hydrogen atoms, so we have to go over here and put a 2. And so that's what we're actually going to have. Now this is balanced. When this reaction takes place, you actually have 2 of these molecules that break apart. These hydrogens will form bonds to each other, and the oxygen atoms will form bonds to each other. This number here is a 1. So the coefficients for this reaction are 2, 2, and 1. Another one quickly. We're going to do this one right here. So the left side has to equal the right side. So we're just going to start with the first element. This is aluminum, and this means we have 1 aluminum atom, and over here we have 2 aluminum atoms. So we're going to put a 2 here, because 2 times 1, this is 2 times 1, is 2. So we have 2 of everything that follows, and that means we have 2 aluminums. Now that gives us 6 chlorines. So we can put a 3 in front of here, and that gives us 6 chlorines. So we're just multiplying this number in front times whatever subscripts there are. Now we have to look at our oxygens. This is 2 oxygens, and this is 3 oxygens. Now how can we get those balanced? We can't put numbers in here. We can't change this. You can only put numbers in front of each substance. So, since this is 2 oxygens and 3 oxygens, if we put a 3 here and a 2 there, that would give us 6 oxygens. Make sure you understand where you're getting 6 oxygens from. But when we do that, we change our aluminum atoms. Now we have 4 aluminum atoms. We thought we had balanced it by putting a 2 here. Well, we have to erase that and put a 4. So now we have 4 aluminum atoms, 4 times 1. But that gave us 12 chlorine atoms. So we have to erase this number and put a 6. So when this reaction takes place, this is actually the amount. 4 of these will react with 3 of these, and it gives you 2 of these and 6 of those. I'm going to write down a couple of more examples, and I would pause at each after I write it down, practice balancing it, and then turn the video back on to see if you got it right. So I would pause right now and try to balance it. And so this should be what you put down, 2 and a 3. So this is 2, 1, and 3 for this reaction here. And we'll do one more. I would pause, try to balance it. And so this is going to be a 2 here, 2 there, and a 3 there. And you won't have anything that's much more difficult than the examples that you've been given here on this video. So you can look at this video. If you need some more practice problems, you can come into class and get them, or you can go online. There are a million websites that talk about how to balance reactions. But these are about as difficult as we really need you to be able to do for this class. See you next time.